Hi, our group is We Love Mold and our project was the injection molder. In today's world, plastic waste is a huge problem, so the idea behind the project was to create a machine that takes in shredded recycled plastic, melts it, and injects it into a mold forming a usable object. We chose to make linking logs. The project included many design constraints and goals. For one, we needed it to be relatively cheap at around $200. It should also be able to run off of a single 120 volt AC outlet. The machine should be able to use different types of plastics and effectively melt them all. It should be portable and reasonably sized, user-friendly, safe, and ultimately be able to make a part in a relatively short period of time. Let's see the prototype in action. First off is putting plastic into the barrel. Then the temperature set point is set for the barrel and the mold. Once the required temperatures are reached, the linear actuator forces the plunger down the barrel, forcing the plastic into the mold.
One for the barrel.
Oh yeah, alright.
So, good to go? Nice.
Bottom out?
Yep.
After it bottoms out, it is then raised back up.
And that fitment between the barrel and that is so good.
I wish I had $100.
Next, the hot mold is unscrewed from the nozzle and cooled off in water. The mold halves are then unbolted from one another.
You can bring it.
Could you bring it Wednesday?
For the demonstration?
Yeah. It would be cooler to have that be the loudest thing in the room.
Then other bolts are tightened which help force the mold halves apart.
That didn't go out much more than that thing is just. The mold is quite over right now.
This time we can just,
Using a bench vise and a screwdriver, the final parts are released from the mold.
A little bit.
oh yeah.
Screwed it out.
Here are some examples of our completed parts. Looking back on the project, most of the design metrics were met. The total cost was around $250, but this could have been cut down in many places. The machine was powered by a single outlet plug and was successfully able to melt different types of plastic, although further testing and refinement is needed for recycled plastics. The final size fits on a desk and is easily portable. The operation is very user-friendly with a display screen and easy controls. The components get very hot and could benefit from more insulation for better safety. And finally, it was able to complete parts in under half an hour if needed. Many upgrades could be made with more time to work on the project. Some of these include water cooling for the mold for faster cycle time, a welded frame, a sheet metal hopper, a valve to control plastic flow through the nozzle, a more refined mold design, and more permanent component placement. All this would serve to make a more professional prototype with higher output and higher quality parts.